And hello, welcome to this video. So today I'm actually doing a little bit of OpenFOAM C. I'm continuing some of the series where I left off. Last time I was talking about icoHeatFoam. Okay, it was a very basic solver. It's a typical thing where you sort of want to add temperature to icoFoam. This is a standard tutorial. You'll find it it's almost universal that you go through it. Okay. Um, okay. So these are typical tutorials. Okay. Of OpenFOAM. But today I just want to start. Looking through the rest of the bits of code of a typical OpenFOAM solver. Okay. So for example, this is what you will find inside the icoHeatFoam. You'll see this facfd.h, pisocontrol.h, all of these things which probably don't make any sense right now. Okay, and okay, so you're trying to make sense of the code over here. Of course, some look a little bit more, how do you say, a little bit more intuitive, like this. FVM, finite volume matrix or something like that, ddt of u plus some divergence, blah, 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 minus FVM Laplacian, blah, blah, blah. Okay, so what they have is this U equation. So the solve command is used for this U equation. U equation equals to some gradient of some pressure. Okay. Yeah, so that's a if loop. So then there are two while loops. Okay. And there we go. That kind of thing. So this is the corrector equation, the piso corrector equation. Yeah, so I'm trying to make a little bit more sense of this code, know what each bit of it is doing. So yeah, so we'll start from a little bit of the more obvious stuff. Okay. First thing first, let's experiment and explore. So this is more of an exploratory video. It's not really that instructional. So it's just to familiarize ourselves with bits of the code. Okay, so let's just do some comparison. Okay, in a typical buoyant pimple foam, so this one is actually what I call dumb buoyant pimple foam. I did very little to edit it, except that it will print extra few lines of text every time. So like this C out, using this namespace C out, you have a few things. Okay, then you have a lot of all these includes over here, which again may or may not make sense. Okay, but let's start with something a little more simple. We'll start with the U equation and P equation. Okay, so over here again, you may or may not you may or may not know this or what, but yeah, just to refresh your memory, the U equation file actually contains all these U equations here, and the reason why you generally want to have all these velocity and pressure corrector equations in another file is because it will get very messy, especially when you have so many things to solve. For example, you have rho equation, E equation, etc., etc. So yeah, for very much more complex solvers, it is much better to shift everything into some other file. So it's a kind of a good practice thing. So yeah, as part of the exploration, let's see what is part of the U equation and what's part of the P equation in let's say buoyant pimple foam or even just pimple foam. Now, buoyant pimple foam is actually a compressible solver, whereas icoFoam is strictly incompressible. Why is buoyant pimplefoam a compressible solver? Because you need to deal with thermal expansion and thermal contraction, so that there's some difference in density. And when there's a difference in density, there's always this natural convection phenomenon. So there are going to be extra features in here which may confuse you. So what I want to do is maybe I'll copy over the pimplefoam directory. Okay, I'll get over the pimplefoam directory here. So what I'll do is I'll do ls foam solvers. Okay, this is the foam solver directory, and I want to go into incompressible. Okay, I'm not going to use tab here because tab completion doesn't work as well when you use this bash, what do you call it? Bash things, bash variables. Or what I can do is this icoFoam solvers. Okay, then I will copy and paste, and I'll ls this. Okay, now I'll do incompressible. Now pimplefoam. Okay, so this is the directory I want to copy over. So copy this solvers incompressible pimplefoam. I'll put it here just as a comparison. So let's go to pimplefoam and let's take a look at the pimplefoam.c and let's compare the pimplefoam and icoHeatFoam. Now the only thing you kind of need to take note in icoHeatFoam is this extra T equation here, at least for this main file. Alright, so let's do some comparison because icoFoam is like the simplest solver you can ever have here. So you have fvcfd.h, both of these are common. The dynamic mesh, which is not present here, it tells you that icoFoam cannot accommodate dynamic finite volume mesh things. Okay. Not only that, you have some single phase transport model, turbulent transport model, which tells you that there's turbulence that you sort of have to take into account. You can take into account using a pimplefoam, but not with icoFoam, which is quite expected. And of course, you have this pimple control, which is the pimple algorithm. Now, before I go through all this list, I would say, in terms of complexity, pimplefoam is much more complex than icoFoam. And maybe one more good place to look is pisoFoam, because pisoFoam is not as functional as pimplefoam, so the code may be slightly less complex. So let's go and look for pisoFoam and copy that here as well. So pisoFoam, I'll copy that here. Let's go to pisoFoam. And let's take a look at pisoFoam.c. And you can see there are indeed less things to worry about. There's no like dynamic meshing or anything like that. Okay, so maybe this is an easier way to start. And if you take a look at pisoFoam, you see this part. If we compare line by line anyway, you see this part, the info line, and then you have a courant number.h, which is common among both. Okay, so first thing here is this momentum predictor. Okay, but over here you will have in this while loop, you will have the pressure velocity piezo corrector. So there's a UEqn.h and pEqn.h. Now let's see whether these things here are the same as what you will find on the left here. So let's take a look at UEqn.h. Okay, here it says there's a MRF correct boundary velocity. MRF, I think, just off the top of my head, might represent what do you call that? Moving reference frames. Okay, so yeah, moving reference frames. So we may have that capability here. So let's compare line by line and see what's the difference. First thing first, you cannot have this FV matrix U equation thing, which is some sort of a class declaration or you're using objects here, okay? And then U equation is, yeah, you kind of declare an object and then you take the class and make it into an object, and you access a function within an object. So that's what this relaxer here is for. Now, obviously over here, it is much more simple on the left. In icoFoam, it is way more simple. Okay, but let's do again line by line. FVM DDTU plus divergence phi of u. So this is this first line here. Then you kind of correct for moving reference frame. Okay, and this thing here is turbulence. Okay, turbulence is not accounted for over here. There's just this Laplacian of nu and u. So this thing, I believe, from the looks of it, it might take into account the kinematic viscosity as well as the turbulent viscosity. So both of them are taken into account here. Now, next thing here, you will notice is this FV options, which is missing here. Okay, probably because in icoFoam you cannot use finite volume options. So those are your function objects and whatever, which you can use in pisoFoam, pimpleFoam, but not icoFoam. So from this code, you can kind of tell maybe, yeah, that's what's going on. So also over here, you will not find this relax and constraint of the U equation. So these are extra features that are present in the solver because you use relaxation factors. Okay, now I assume you know what relaxation factors are. If not, you can go and check out my OpenFOAM intermediate series, or if you're so fancy, yeah, some other video. Okay, but I have it in my OpenFOAM intermediate series. You will see in the description below. Now, let's see. This is the pisoFoam. Let me close this. Maybe now maybe the desktop background looks nicer. Okay. I have close this. Hold on. Let me close some files to make it neater for you. Okay. Maybe this is less distracting. I'll just have this in the background. Alright, let's go back where we were. Okay. Or maybe I just use the desktop. Okay, back to desktop. As you can tell, I like a really clean desktop. It looks very nice. I don't like clutter. I'm just decluttering things. And okay, so anyway, let's go through this part again. The U equation. And what I like to do is, of course, try to like, what do you call that? I want to try to play around with this code, recompile, and execute. Okay, so for example, in this case, I want to go and check out icoFoam. Okay, over here it looks like I have icoHeatFoam being run. Okay, so this is for icoHeatFoam. Okay, this cavity case is for icoHeatFoam. So if I run icoHeatFoam there, it should be able to run. Now what I want to do is to sort of make the files neater. Okay, what am I doing here? Must be a bit late. Custom solvers. Okay, icoHeatFoam. Okay, so this is icoHeatFoam. Let me copy over. icoHeatFoam, experimental icoFoam. Experimental icoFoam. And let's go to experimental icoFoam, because I will just play around with equations here. So I'm going to vim icoFoam, icoHeatFoam.c. I'm going to change it, yeah. Move icoHeatFoam.c into experimental icoFoam.c. And I'm going to change my make file. Okay. I'll remove this part because it's pretty redundant. Vim files. Experimental icoFoam. Experimental icoFoam.c. Okay. Experimental icoFoam. Okay, so that will be my exe file. And let's do some things to change. Okay. Now, actually, what I first want to do before I start modifying this code is to kind of just tidy this part up. So I like to bring all these over into an include, so that I have a UEqn.h. So what's the code I need to bring out? And I can actually examine the pisoFoam code, and I just compare line by line, try to make sense of what the code is. Okay, just by looking at the syntax. Now I don't have at the moment I don't have any background as to what these function and what these objects are. I can only guess and sort of reverse engineer from there. And of course you can look at documentation later on. Okay, but let's tidy this part up first. Okay, so we notice that the include coral number.h is not included in the UEqn. Only this FV matrix UEqn blah blah blah, and of course the piezo momentum predictor part. Okay, so this is what should be in the UEqn. So probably just going to copy and paste, but there's no MRF thing here, so we are not going to include that. So let's copy and paste this, and we'll touch UEqn.h. So let's go to UEqn.h, and then we'll just paste it here. Okay. I don't know why this is all there, but let me shift it to the left. So I use visual. Okay, press V in a Vim, press V, and then you shift, and then you go to the greater than or equal greater than or less than. Shift greater than or less than. So that will help you to indent. Okay, so shift the greater than or less than sign. Okay, so that's what it will be. So let's look at UEqn.h to make sure we have everything. First thing, we have the FV vector matrix UEqn. There's no FV options here, so we'll just leave that out. No relaxation factor, no FV options. The next thing is the piezo momentum predictor, which is this part. Okay, so it says that all the terms here is equals to the pressure gradient. So let's do that. So that's the UEqn. Let's go to experimental icoFoam.c and just try and tidy this thing up with the include UEqn.h. I'm going to delete all of this. Okay, and I'm going to put include UEqn.h. Okay. Now, normally what I like to do is just to compile this straight away and see what happens. But I'm going to, okay, never mind. Let me just compile this straight away, and then you'll see if we can compile successfully and run icoFoam successfully. Okay, so let's wmake. Okay, so it's compiling. So I'm still using OpenFOAM 2006, which is an older version. By the time of this video, 2012 should have come out, and I believe 2106 should be out pretty soon. I mean, judging by the way ESI likes to release their OpenFOAMs. But I believe the way the code runs is still more or less the same. But anyway, okay, while we are waiting for this to compile, oh, it's already been compiled. Okay, yeah, since it's compiled, let's check whether it works. Custom solvers, oops, custom cases, and let's go to cavity. We'll just run block mesh experimental icoFoam, and looks like it runs perfect. So I just run a clean file, and that's great. Okay, let's go to custom solvers again, and I want to remove. Okay, I want to recompile. Yeah. So we can see that this trick of putting it into an include actually works, just to make it neater, tidy up your code. So let's go again to experimental icoFoam.c. All right, vim experimental icoFoam.c, and let's tidy up this part of the code. So this is what they like to call the P equation. Now let's see where the P equation is supposed to go. So you can see there's a while runtime loop. This is the same as here. You have a current number, same as here. You have a UEqn UEqn.h. Okay, inside this bracket over here. I hope I'm doing things right. So there's a while loop. Okay, there's a this while loop over here. Okay, but I mean everything looks okay. I mean except for the extra curly braces. So this is this bracket here is for this while loop. And then there's a second bracket set here for this next while loop. Oh, there are 3 while loops. Okay. So whereas over here there are only 2 while loops. Okay, so let's see. Okay, you see this part, it says, if you want to compare like code by code, this part it says while piso correct. Yeah, while piso correct. And then this whole part over here is basically this p equation.h. So if I'm correct, if I'm not wrong, the include will this p equation.h that's included will include all of the code that I'm highlighting over here. So let's take a look at p equation.h. All right, so as you can see, first part here pretty similar. Okay, I won't explain what these terms are, but I'll just confirm code line by line roughly, is it the same or not. Okay, volume scalar field, that's the first one. Then you have a volume vector field of something, surface scalar field, and all these terms in the bracket. Again, the only difference here you can see is this MRF0 filter something. Okay, MRF filter here, it's FVC interpolate. Okay, so this is the code that's over here. Next thing, it's MRF stuff, which is missing from here. There's no equivalent line. Justify is over here, and this one's update pressure BCs to ensure flux consistency. Same for pisoFoam as it is for icoFoam. Then you have this non-orthogonal pressure corrector loop. Okay, same lines of code here. Then you have a FV scalar matrix, FVM Laplacian of RAU and P equals to divergence of whatever this thing here. I don't even want to pronounce it. Okay, and these 2 lines, again the same. These 2 lines, again the same. These 2 lines here, again the same. And oh, look at this. We have an include continuity error.h. And all of these things here, which are the same as here. These 2 are the same. And then, okay, you have one more, FV options correct U, which is missing over here. So, rightly so, everything here should be copied over and pasted or cut and pasted into a p equation.h if we want to tidy up the code. Let's just copy and let's vim p equation.h. Okay, and we'll paste everything here. Okay. Of course, as usual, we want to bring everything to the left. So I like to use Vim. So we'll just use the visual mode and shift and right. Shift and left, sorry. Visual mode again. Shift and left. Okay. Okay, so these two look almost identical now. So we have some confidence that it is safe. Okay, so next thing, experimental icoFoam.c, let's do the include. So let's just look at pisoFoam.c for reference. Okay, so you have this thing in the while piso correct. Okay, so let's just follow the code. I'm going to type 4 spaces include pEqn.h, and then everything else inside this while loop will disappear. Oopsie. Undo. Undo. Okay. So the last line in the pEqn.h should be for correct boundary conditions, which is over here, which is perfect. That's exactly what we want. We can do a wclean, ideally, and wmake. And then we'll compile everything. If everything goes well and we did make our code now have all these includes, then we should be fine. Okay, so tidy up the solver files into the includes. Okay, so all right, let's see whether this works now. Let's go to custom cases. We'll go to cavity and we'll run block mesh again and experimental icoFoam. And look, everything looks quite okay. Okay. All right, so I think that's it for today. Just something very simple. We're just tidying up the bits of code into the include, so that if you want to make it such that it's more yeah, we make the code more readable, tidy it up. Now this is a good practice. Okay, so I think I was like trying to go through a lot in the beginning, but I might. Okay, yes. This is what the video is about. I think that is it. As usual, you can take a look at the description for the GitHub link. Okay. And I'll see you next time. Bye bye.